Hello, and welcome back to our series on data science. In part one, we studied the main terminologies associated with data science, and now I am going to present the concept of data science itself. As was done in the previous part, I will bring some concepts from the literature, and then I will present my own perspective of the field, consolidating its knowledge and applications. This part ends with a presentation of the data science workflow. Its understanding helps the planning and execution of data-related projects and the positioning of the many professionals along the data science journey. Although in the previous part of the series, we talked about many different terminologies like machine learning, KDD, data analysis, data analytics, and big data, we didn't talk about yet the central theme of this series, which is data science. In this part, we are going to present some concepts about data science and then the data science workflow, which is a key element for us to understand the different careers that we have in the field and what are the main roles of each of the professionals in the area. Let us start revising some concepts from the literature. First, let's go to the paper titled Data Science by Kelleher and Tierney. They define data science as a set of principles, problem definitions, algorithms, and processes for extracting non-obvious and useful patterns from large data sets. Then, we have the definition presented by Provost and Fawcett in a book titled Data Science for Business, What You Need to Know About Data Mining and Data Analytic Thinking. They define data science as a set of fundamental principles that guide the extraction of knowledge from data. And it's very interesting to look at these two definitions because they are pretty much the same definitions that we presented in the previous part about data mining. And it's also, if we have a look at the title of Provost's book, it's mainly saying that data science is related with data mining and data analytics, which are two concepts that we discussed previously. And as we saw, there is a very close relationship between all these terminologies. One last concept from the literature that is worth having a look at is the one presented in the paper by Kao, titled Data Science, a Comprehensive Overview. He defines data science as a new interdisciplinary field that synthesizes and builds on statistics, informatics, computing, communication, management, and even sociology. And the goal is to study data and its environment. And by environment here, we mean the hardware infrastructure and the software infrastructure, just as we discussed in the previous part as well. And then he talks about the goal. He says that the goal of data science is to transform data into insights and decisions. I want to synthesize all this discussion about what is data science using a different approach. Basically, what I want to do is to take a higher level in the discussion, divide the concept of data science in its two main parts, which are data and then science. When we look at science, science is basically a principled approach in which we have a problem that we want to solve or that we want to analyze. And based on this problem, we draw or we devise some hypotheses that have to be either validated or refuted. And we take this hypothesis, we gather or we collect data, we perform some experiments, we gather the results, we evaluate the results, take some conclusions, and if necessary, we review the problem and the hypothesis, and the process cycles again. That's the basic idea of the scientific process. I want to discuss now the main goals of data science. When we talk about extracting knowledge from data, and we've seen that many authors use this idea that the goal of data science, the goal of machine learning, the goal of data mining, the goal of KDD is to extract knowledge from data. But what exactly does that mean? I want to divide that in three different types of uses of the data science or data mining or KDD process. One of them is what we call insights. The idea of insights is that you have some patterns and knowledge hidden in the data, and by analyzing the data, you want to reveal these patterns that are hidden. For example, I can take a variable related with the height of a group of students, And by analyzing this variable, I can note that I have some students that are above the average of the height of the group of students, and I can find some students that are below the average. Right? So these are some insights that are hidden in the data that you can find when you analyze the data. Another use is, for example, let's say that we have a number of X-rays of the lung, and what you're trying to find in the X-rays are, for example, indications of cancer. You can design an intelligent system or a machine learning system that is capable of analyzing these X-rays and telling you, for example, the probability that a certain X-ray presents lung cancer or not. This system is going to be used as an assistant for the physician so that the physician can look at the X-ray, can look at the result provided by the machine learning system or by the data science system and use that information as a support for his decision. In this case, the system is not taking the decision by itself, but it's supporting a physician to take his or her own decision. And finally, we can also design a data science system that is going to automate a specific process. For example, let's think about the case of automating, for example, the process of classifying fruits. Let's say that we have some apples and bananas passing through a belt, and this belt has a camera that captures the images of these fruits and has to automatically classify the fruits into bananas and apples. The goal of your system is to automate this process such that you don't need a human being doing this manual classification. In summary, what we have here is the extraction of a hidden pattern, which we are calling here insights, or the design of a tool that is supporting a certain professional, for example, a physician, or the automation of one specific process. So these are the three main ways that you can use a data science solution. If we want now to put all these fields into perspective and into context, we can say that data science is the field that branches out to all the other fields that we discussed so far. We've seen that machine learning is more focused on learning from data or how machine learns, and also it's more centered in the algorithms themselves. Data mining in KDD talk more about the process, and in many cases, data mining is one step of the whole KDD process. Data analysis is more concerned with descriptive statistics, data visualization, and dashboard design. Data analytics is more focused on the inference, on the generalization, on the creation of models that are capable of extrapolating from data. And big data includes not only the data, but also the hardware infrastructure to store and process data, and also all the analytical processes to extract value from the data. I want to finish this part by presenting a different workflow from those that we saw when we studied KDD in the previous part. Here, I focus more on the whole process of solving a problem, of creating a specific solution to solve a problem, from the time that you map and understand the problem that you want to solve until the moment when you develop and validate the solution. The proposed workflow has 5 main steps. The first step, we call it analytical mapping. And what it means is that this is the moment when you're going to study the problem that you want to solve. Let's take the example of analyzing lungs X-rays. The first thing that you have to do is to understand what are the characteristics of the problem, what are the characteristics of the images, in this case, the X-rays that you're going to use, what you want to extract from it, how to characterize the different types of tumor that you may have. So everything related with the problem you do here in this step that we call analytical mapping. This includes business analysis, the requirement analysis, the design of the use cases, and also it's very important for us to be capable of saying what the machine learning, what the data science techniques can do for solving your problem. And this requires knowing the different types of learning approaches, knowing the different types of algorithms that we have, so that we can decide in this step what type of solution we are going to propose. This analytical mapping step is very important for you to think about your problem and to think about the types of solutions that you're going to design and test in your whole process. The next step is to collect the data itself and to prepare the data for analysis. Preparing the data for analysis may include to deal with missing values, to normalize the different variables, to standardize, to integrate different data sets, and all those steps necessary to prepare the data so that you can apply specific algorithms and techniques to extract knowledge or to build model or to infer something from the data you do in this step 2. The next step involves data analysis. Here, we are talking about the application of descriptive statistic methods such that you can characterize and summarize your data, the application of visualization techniques, and if necessary, the design of dashboards. Note that none of these techniques are extrapolating the data, so you're not making any inference here. You're just analyzing and trying to find some insights from your data. After you do that, you go to the analytics part, and only in the analytics part that you're going to apply machine learning algorithms, that you're going to be able to infer something out of your data. For example, you're going to do some predictions, some clustering, you're going to find association among variables. All these tasks are performed here in the data analytics steps. After all that, you're going to test, you're going to assess if the performance of your solution is satisfactory. For example, let's say that you want to detect lung cancer with an accuracy of 90%. It is in this stage, in this last stage, that you're going to do this validation. And if your solution satisfies all the prerequisites, then you can integrate that into the final solution, or you can deliver your final solution to the problem. The last comment I want to make about this workflow is the fact that we have this bar here at the bottom, and we have these double arrows connecting all the blocks. This means that the process is iterative and interactive, in the sense that I can go, for example, from any one of these steps to a previous one or to a forward one, depending on the result that I get. Let's say that I don't have the accuracy that I wanted, and I find out that I need to work with different variables. So I have to come back to this step here, collect new variables, insert them in the data, and do all the analytical process again and validate the final result. This may happen in any step of the workflow, meaning that you can go either forward or backward, depending on the results that you obtain with your process. Thank you for watching, and see you in our next part of the series.